Hey calculus kids, this is Dr. Callahan with week 6 Friday. How are you guys doing? You guys made it to the end. Go ahead and pause the video and answer the following 3 questions, and we will go ahead and get started shortly. All right, let's go ahead and add your assignment for today. So today is week 6 Friday for Calculus AB semester 2, and our topic of discussion is going to be on the 3 derivative rules of log ln and base of a to the e. So this is going to be the second day, kind of like a review summary of everything that we've discussed. Please go ahead and check in with me with attendance by 9:41 a.m. You have until 3 p.m. to turn in and upload your assignments, so just keep that in mind, and I'll go ahead and assign this. All right, let's go ahead and get started with today's stuff. This is a breakdown of what we're going to be talking about, so take a moment and read that. Your kind of note today looks like the following. This is your first page. And we're just going to start off on this first page right here. Okay, so make sure you guys get to that page. All right, so looking at this right here, change of basis. So when you have log a of x, you can actually rewrite that as ln x over ln a. And so let's take a look at example 1. With example 1, if I were to go ahead and apply this, looking at this part right here, I have 3 to the x equals 1 over 81. So I could put log base of 3x equals log 3, 1 over 81. Looking at this part right here, the log 3 with a 3 cancels, and x equals log base 3. Another way of writing 1 over 81 is to have 1 over 3 to the 4th. And of course, if I rewrite that, I could have 3 to the negative 4. And if you look over here, I can go ahead and cross this part out. So x equals negative 4. Let's take a look at example 2. With example 2, you could do a 2 log 2 to the x is equal to 2 to the negative 4th power. So we're just basically inserting 2 on both sides. Now looking at this part here, 2 log with a 2 cancels, and x is by itself, which I can write it as 1 over 2 to the positive 4th, which is 1 over 16. And that is your answer. Derivative rule for logs of other bases. So log a of u is equal to 1 over ln a times u prime with a u prime on top. So this is going to be equal to 1 over ln a times u prime over u. So that I have the derivative of log what just happened? Okay, let's try this one more time. My pen's having a little bit of a technical problem, so let me redo this. Log A, x is equal to d over dx ln x over ln a, which is the same thing as 1 over ln a times 1 over x, which is equal to 1 over ln a x. And then also, if you recall, derivative of ln u is equal to u prime over u. Similarly, the derivative of log a of u is equal to the derivative of ln u over ln a, which is the same thing as 1 over ln a times u prime over u. All right, let's go on to some example. Example 3. Find the derivative for f of x equals log sub 5 cube root 2x squared plus 7. So I'm going to go ahead and try to rewrite this without a radical. So we have log sub 5 2x squared plus 7 to the 1/3. Now I could bring the 1/3 down. So I have a 1/3 log sub 5 2x squared plus 7. So let's go ahead and find the derivative. The derivative of this is going to give you a 1/3 log sub 5. You're going to go ahead and do a 1 over ln 5 times the derivative of 2x squared, which is u prime, is 4x over 2x squared plus 7. And if I rewrite this, I will have a 4x over 3 ln 5, 2x squared plus 7. And remember, you're using this one with your formula here. Okay, let's go ahead and go on to example 4. So for example 4, I would like you guys to go ahead and pause the video and give that one a try and see how far you're able to get to it, and then we'll come together and solve it together. All right, let's go ahead and take a look at the next piece of this. Okay, so looking at example 4, I went ahead and pasted the derivatives rules up here so it's a little bit easier for you guys to kind of look at this while we're doing this example. So for example 4, I see I have the log right there. I want to go ahead and expand it because of the division sign. So I have f of x is going to equal to log the numerator 5x cubed minus the denominator log x squared minus 3x cubed. Now you do have this part here which you can bring it down. So we have a log 5x cubed minus 3 log x squared minus 3x. Now that we have kind of like primed this up, we can now go ahead and apply with the derivative, which as you can tell, you can go ahead and apply directly. So then my f prime of x is equal to log sub a is going to be 1, or excuse me, it's going to be 1 over ln a. So I have 1 over ln a times u prime. So u in this case is going to be 5x cubed. So then u prime is going to be 15x squared over u. So that's going to be 5x cubed. I know this part says u prime over u prime. It's not that. It's u prime over u. Okay, so just be careful with that. That's just a minor little typo. And then minus 3, looking at this right here, the derivative of log, okay, your u in this case is going to be x squared minus 3x. U prime is 2x minus 3. So this will be a u prime. So your u prime is 2x minus 3 over ln a. ln a is x squared minus 3x times u. And your u is x squared minus 3x. So another way that you can write this is you can go ahead and do ln a. And if you look at this, your a actually in this case is going to be just a subset, which is going to be a 10. So I would do 1 over ln 10 times u prime over u. So u prime is 2x minus 3 over u x squared minus 3x. And this is what you have. And then looking at this here, we can go ahead and multiply this through. I'm trying to figure out how do we want to go proceed this. Well, this part right here, we can take it as a minus 3 times 2x minus 3 over ln 10 times x squared minus 3x. And at the beginning of this, you can go ahead and reduce a little bit. 15 and 5, you do a 10 and a 3 and a 1. So then we will have a 3 over x, and also the x squared, x cubed just cancels, ln a. And this is what you should have as y prime. And that is your answer. And before I forget, I just want to make sure I make a little change here and a little modification so that way I don't get the kids confused. So I'm just going to insert text right here. And just want to make sure that we don't have a little typo here tomorrow morning when I teach this lesson. So insert, it's going to be u, put correction, u prime over u. There we go. All right, so then let's go ahead and go on to the next part here. Okay, so the derivative rule for exponential function base of a, which we talked about yesterday as well, follows that right there. Okay, so then looking at this right here for example 5, and before I do that, I'm going to talk to you guys a little bit about this. So remember that the e to the ln x is just going to be x because e and ln cancels. So then as such, the derivative of a to the x is going to be equal to e to the ln a x, which tells you that the derivative of e to the ln a x is equal to is equal to e to ln a x times ln a, which is equal to ln e to the ln a x, which is equal to ln a times a to the x. So now let's go ahead and apply that concept to example 5. So to find the derivative of this, you're going to have a equals 5. U is going to be x squared minus 2x. Du is 2x minus 2 dx. And then dx is going to equal to du over 2x minus 2. So let's find the derivative of this. Derivative of this is going to give you, okay, so f prime of x is equal to ln a, so that's going to be ln 5, times a to the u, so that's 5 to the u, so that's 5 to the x squared minus 2x, times u prime, and my u prime is just going to be 2x minus 2. So technically, I didn't even have to do any of this part right here, so cancel that part out. That's only for integrals. And that is your answer. That's it. It's pretty straightforward. Write it out. Let's take a look at example 6. So in this case, we're going to do a little bit of a product rule. So then your f is going to be x, f prime is 1, g is equal 4 to the negative x. So then your g prime is going to be a little bit longer in this situation, because if I compare this 4 to the negative x with this derivative, a is 4, u is negative x, u prime is negative 1, so u prime is ln a, so ln a, which is ln 4, times a to the u, which is 4 to the negative x, times u prime, which is negative 1. Now if I go ahead and clear this up a little bit, I will have a negative 4 ln 4 to the negative x. Okay, so then now that I have components of this, I'm going to do f prime times g plus f times g prime. So f prime times g is just 1 times 4 to the negative x, which is going to give me 4 to the negative x, or I could just put 4 to the positive, 1 over 4 to the positive x, plus f times g prime. So here's f times g prime, which is just going to give me it's going to give me negative 4x to the ln 4 to the negative x. If I go ahead and rewrite that, I will have 1 over 4 to the x minus x to the ln 4 over 4 to the positive x, in which case I can go ahead and write as 1 minus x ln 4 over 4 to the positive x with a common denominator. Okay, so then F times. All right, with that said, let's go ahead and proceed on forward with this. And I just kind of made it realize that I made a little typo. That negative x right here is with a -4, not the ln. So I need to move this back a little bit. So this negative x is actually right here. There we go. Sorry about that. All right, now let's take a look at the last example, which is a Fourier science question on the particle and velocity. Okay, so it says A, write an expression for the acceleration of the particle if v of t equals t times ln t minus t. Okay, so it's given to you that v of t is equal to t times ln t minus t. So then you know that a of t is equal to the first derivative of v. So then what is the derivative of this going to be? Well, you will have to go ahead and apply the, well, let's see. So let's go ahead and apply the rules here. Okay, so I'm going to have a product rule right here. So then my f is going to be 1, my g is going to be ln t, and so then f prime is going to be 0, and g prime, ln t, derivative of ln t is just 1 over t. So let's take a look at just this part first. Okay, so f prime times g, my pen is malfunctioning again, sorry guys. Okay, f prime times g is just going to give you 0, so that's not going to do anything. Plus f times g prime. So that's just going to be 1 over t first. Minus the derivative of 1. All right, so then let's take a look for B. For B, we are going to be looking at for what value of t is the particle moving to the right. So we're going to have to find the critical point. So V of t is equal to t ln t minus t. So then let's go ahead and see if we can factor out a t. So that's ln t minus 1, set equal to 0, t equal to 0. And if you go ahead and solve for this right here, then what I'll have is ln t minus 1 equals 0, ln t equals a positive 1. So then if I put an e right here, then t is equal to e. So these are my critical points. So let's go ahead and check them on the sign line. So I know e is bigger than 0, so here we go. Let's put an e right there. And then you're going to go ahead and pick a point. So we're going to do v prime of -1, v prime of 1, and v prime of 3. And you should be able to see that from here, between 0 and e, you're going to get a negative. After e, it's going to be a positive. And so what you can say here is that the particle moving right at e positive infinity because v of t is greater than 0. All right, so then let's take a look at C. What is the minimum velocity of the particle? Show the analysis to your conclusion. All right, so with that one, I'm gonna have you guys go ahead and pause the video and answer it on your own. Give it a try. All right, so let's go ahead and take a look at that part right here. So this is your part C, so go ahead and take a look at my work for that. All right, you guys, let's go ahead and take a look at the rest of the part of this. So what I would like you guys to do is go ahead and take a look at the practice problems from your textbook. I do have a link right over here that you can watch the video that will go over this as well. As always, stay safe and healthy, and I'll see you guys next time. Take care.